Assalamualaikum warahmatullahi wabarakatuh and good afternoon. So this week is week 12. So we're going to continue on the tutorial on chapter 4. Three-phase circuits. So let's look to our first question. So what is the phase sequence of a balanced three-phase circuit for which VAN, so this is the, call it a line voltage. Is it line voltage? No, it is the phase voltage because it refers to the neutral line AN. What we call line voltage is referring to the main line A to B or B to C or A to C. So if it's referred to AN, so this is the phase voltage referred to the neutral. So we have phase voltage AN 120 angular 30 degree and CN 120 angular negative 90 degree. So right now we have to find BN. So the solution here says phase C lag by 120 degree. So basically this is ACB sequence. So how actually we know that this is lagging 120 degree for the phase C. Okay, so we know that every the difference between phase is 120 degree, right? So if you look at this, it is different for with 120 degree, but is it plus or minus? So if you look at this, VCN is minus 90 degrees. So if you plus 120 degree, you will get VAC. So basically that's why the sequence is ACB. Okay, let me write something here. So if you have A, C, B, so right now C is minus 90. So if you find out that the difference between A and C is plus 120 degree, so if you plus plus this value minus 90 plus 120 degree, you will get this value here. So that's why the sequence is ACB, and for this one it should be 120 degree. So minus 90 plus 120 degree and minus 120 degree, you will get minus 1210. Okay, so this 1210 basically is positive 150 degree lah. Okay, so that's why we have the answer VBN is angular 150 degree voltage, and the magnitude should be the same because it is a balanced circuit, three-phase circuit. So for the next question, determine the phase sequence of a balanced three-phase circuit in which VBN is angular 130 degree and VCN is equal to angular 10 degree, and obtain VAN. So okay, so if you write down like this, ABC, we know that B is 130 and C is 10 degree. So this is basically 110 different. So this it should be 100 and plus 110. So this is negative, this is plus. So if you plus here, you get 250. So this is basically is the sequence of ABC sequence lah, because the difference between this should be 120. Okay, so this ABC sequence, so this is right. So if you look at this, the answer of VAN should be this one. Okay, so however they put it 110. If you deduct 360, basically you will get minus 110 degree here. Okay, so that's why the answer is like this, or you can write it plus 250. So okay, so the next question is a three-phase system with ABC sequence and line voltage equal to 440 volt fits a Y connected load with ZL load impedance equal to 40 angular 30 degree ohm. Find the line current. So we need to find each of the line current A, B and C. So first we have to find the phase voltage first. Okay, so to find the phase voltage, we know that VL is equal to square of 3 VP. Okay, so this is VL, so VP should be 440 divided by square root of 3, square root 3. So this we will get you get 254 volt. Okay, phase voltage. So if you know the phase voltage, we know the phase voltage of each line AN, BN and CN. So VAN equal to 254 and 4 angular 0 degree volt. VBN should be the same magnitude, 254 angular, this is minus 120 degree volt, and VCN equal to 254 angular plus 120 degree volt. So this is formula of it, so we can generate it, simply generate it. And to get the line current, for example IA, you can use VAN here, VAN over Z load. So Z load is the 40 angular 30 degree. So VAN is 254 angular 0 degree divided by 40 angular 30 degree. So this you will get 6.35 angular minus 30 degree ampere. Be the same, 254 angular minus 120 degree divide by the which is the Z load, 40 angular 30 degree. So this you will get the magnitude should be the same, 254 divided by 40, you will get 6.35 angular minus 150 degree ampere. So minus 120 deduct minus or deduct substitute 30 degree, so you get 100 minus 150 degree. And IC you will get 6.35 angular, so this is plus 120 minus 30, you will get 90. 120 minus 30, 90 degree ampere. So this is your result. Okay, for this question they give you time domain expression, line to neutral or voltage phase, VAN, BAN and VCN, and this is Y connected load. And then they ask us to find the time domain expression for line voltage, VAB, VBC and VCA. Okay, for this first we have to convert this phase voltage to the line voltage first. So let's look into the first VAN. Okay, so VAN is basically 120 angular 32 degree. So to change the VAB, for example, 120 we have to times with the set 3, and the angular should be plus 30. Sorry, this is 32. Wait. (32 plus 30 degree). Okay. So here you will get 207.8 angular, 62 degree volt. Okay. So how I get this formula? So you can refer it into in the slide given in the summary. So this is Y to Y connection. So if you look at this, VAB, it start with 30 degree. That's why I add the 30 degree in the formula, in the answer. And the formula for BP, you have to multiply or time it with square root 3. Okay. So in time domain formula, VAB will be 120 cos WT plus 62 degree volt. Okay. So for the next phase, VBC, so the phase should be the difference between between it is should be 120 degree, right? So we have to minus it, minus 120 degree. So it should be 27.8 angular 62 minus 110. You will get 207.8 angular minus 58 degree volt. And VCA will be the same. We have a difference of plus 120. So this one you will get angular 62 plus 120 degree. So this one you get 27.8 angular 120 62 182 degree volt. Okay, so this is the answer, but you have for the final you need to change it to time domain expression like this one, but all the info is here lah, the degree and the magnitude. Okay, hope you understand. So let's continue to the next question. In a balanced three-phase YY system, the source is an ABC sequence of voltage and VAN equal to 100 angle 20 degree volt RMS. The line impedance per phase is 0.6 plus Z 1.2 ohm, while the per phase impedance of load is 10 plus J 14 ohm. Calculate the line current and the load voltage. So this is basically the solution of it, a circuit. So it's better if you have this kind of question, you try to draw the equivalent circuit. Okay, so we have VAN and we have a line impedance, and also we have a load impedance. Okay, so this line and load impedance is parallel to each other. So we need to find the line current and the load voltage. So the line current, the current that flows into this line, and also the voltage across this load ZL. Okay, so this is VL. Okay, and IL. So to find IL, I think it's simply because it already gave you the voltage of the line VAN. IL should be VAN over Z line plus Z load. Okay, so VAN 100 angular 20 degree and these two. Okay, 10 plus 0.6, you get 10.6. 1.2 plus 14, you get 15.2, plus j 15.2. Okay, so if you use the calculator, you get the answer of this one, basically 5.396 angular minus 35.1 degree ampere. Okay, so now we have to find the load, voltage load. So we already know the current flowing into the ZL, so basically we can find the Z load. Okay, so I forgot to tell you that the one that we are calculating is for IA. So we also need to find IB and IC. So we just use the information that we get from the answer that we get from IA. So this is 5.396 angular, so this is minus 350. So we just minus 120. So you will get minus 120 minus 35 minus 155.1 degree ampere, and IC is plus 120. So you'll get angular 120. Let me use my calculator. Minus 35.1, 84.9 degree ampere. So this is you need to remember minus, and this is plus 120 of this value here, right? Okay. Okay, now we need to find the voltage load. So first we find the A first. So IA times dengan ZL. So IA is 5.396 angular minus 35.1 times with the ZL, which is where is ZL, 10 plus J 14 ohm. So here you will get answer of 92.84 angular 19.35 volt. Okay, so the same goes to VLB and VLC. So for VLB, the answer is 94.84 angular 100 minus 100.65 degree volt, and VLC you will get 94.84 angular 139.35 degree. So this one is basically 4. Okay, so that's all for this question. We try to discuss the next question, basically the last question. So this will be the last question that we're going to discuss today. A balanced YY 4-wire system has phase voltage VAN, VBN, VCN. They gave it everything here, 0, minus 120, 120 degree phase. The load impedance per phase is 19 plus J13, and the line impedance per phase is 1 plus J3 ohm. Solve the line current and neutral current. So we need to find both line current and neutral current. Okay, so first we're going to find the line current. So line current, we find I1 plus first. So it should be VAN over Z what? Z load or Z total, which means Z load plus Z line. Okay, so we have to add both this value. So VAN is 120 angular 0 degree divided by ZL. So we have to, because it's in series, just add it up. So 20 plus 13 plus 2, 15, J15. So this you will get 4.8 angular minus 36.87 ampere. Okay, so for the next IB and IC is a bit simpler, because we have the result of IA, the current IA. So for IB, the magnitude should be the same, 4.8 angular, so this should be minus, we need to minus 120. So minus 120, you get 156.87 degree ampere minus okay, and IC 0.8, so this is plus. So if you plus this one, you will get 83.13 degree ampere. So this is plus. Okay, so you already get the line current. So the neutral current basically will be IN, which should be 0 ampere, because it is a balance three-phase circuit. If you look at this, why it's balanced? Because the magnitude and also the phase is, the magnitude is the same, the phase is different of 120 degrees. So the neutral current is 0 ampere. Okay, so that's all for today. We're going to continue next week on this still on this chapter tutorial. Okay, so assalamualaikum and good day.